Okay, so today we're going to tackle a lot. We're going to talk about piecewise defined functions in real world situations. So here we have an example of residential power cost, excluding fuel adjustment costs and taxes. The rates of Georgia Power Company charges its residential customers for electricity during the months of October through May, and this is shown with this table below. I would like to draw your attention to the fact that there is one minor mistake in this chart, and that is that this should only have 1 3 in it right here. So this should read $37.50 plus 0.03946 per kilowatt hour above 650. If we were to write a piecewise defined function that represents this table, this situation, okay, we'd have to look at each piece individually. Again, the monthly kilowatt hours, okay, this is our X. So these are going to be our subdomains. Okay, and then the monthly charge is our Y. So these are our subfunctions. All right, so what would this look like? Okay, from the subdomain of 0 to 650 kilowatt hours, the monthly charge from Georgia Power is $7.50 plus 0.045991 times the kilowatt hours. So that's our X. So our subdomain here is if the kilowatt hours is between 0, including 0, and 650. But once we hit 650, we jump to the next level of charges. So this level of charges is $37.40 plus 0.03946 per kilowatt hour. That's our X. Oh, but we have to subtract off, sorry about that. We have to subtract off a certain amount because we've got kicked up to the next level. So I need to subtract off the 650. Okay, so that piece of it, all right, is determined by the fact that I'm on the next level. I'm not going to get charged everything up until that point. It's just I get charged this amount once I hit 650. So I have to subtract off the 650 in this piece. So this is the charge only if my kilowatt hour usage is between 650 kilowatt hours and 1,000. Oh, that's tight over there. All right, then the next level is the piece of if I use kilowatt hours greater than 1,000. So this is 5121 plus 0.038737, but only if I use kilowatt hours past 1,000. So I have to subtract off the 1,000. So if X is greater than 1,000. All right, so if I wanted to know what would be my charge, okay, so what is C of 950? So maybe instead of F of X, this should have been C of X. And it does define it as C of X. Okay, so what would be my C of 950? So I'm going to plug in 950 in for X. Well, 950 uses this middle piece of the piecewise function, right? Because it falls between 650 and 1,000. So I'm going to plug in 950 to the middle piece, 3740 plus 0.03946 times 950 minus 650. Okay, and if I were to calculate that, I would get 49.2. Let's see. Let's round it off to 2 decimal places because it's money. Okay, so $49.24 would be my charge or my monthly bill, okay, if I were using 950 kilowatt hours. So that's what that means. Okay, let's find the charge for using 1,560 kilowatt hours. Well, that's past 1,000. So I'm going to use the last function to calculate this. So if I were a big business and I used a lot of power, like 1,560 kilowatt hours, then I would plug into this formula, 37 times 1,560 minus 1,000. Okay, calculating and simplifying this, I would get 72,903. Let's see, that needs to become $72.90 per month for using that amount of kilowatt hours. Now, we're going to use a graph of this function to determine how many kilowatt hours would be used if the monthly charge were $122.87. We see that from the previous one, it's going to be greater than 1,000. In fact, it's going to be greater than 1,560 because using 1,560 kilowatt hours yielded a monthly charge of $72.90. So we're going to need more kilowatt hours of power usage in order to yield a monthly charge of $122.87. So we're going to graph this function on our calculator. Okay. Okay. And essentially, it should look like this for the first half, and then you put in your subdomains in for the second half. Probably the trickiest subdomain is the middle one, because you have to remember to divide it into 2 separate ones. The other thing is, you might recall that last time we got that little red line that wasn't included. I figured out how to eliminate that, and that's by putting the compound inequality within another set of parentheses. And then that will clean up your graph a little bit. All right, so take a moment to enter this equation into your calculator, and then we're going to let y equal 122.87. Okay, we're going to put that into y4 because this is our cost, and what we're trying to figure out is what is our kilowatt hours. Okay, so then we're going to also restrict our window to go from 1 to 3,000 on the x, and then on the y from -5 to 130. All right, let's see what this looks like. Okay, so the blue, red, and black lines represent the piecewise defined function, and then the pink line, or the fuchsia line, represents the function y is equal to 122.87. So we're going to see where these two lines cross. Okay, so we're going to hit second, calc, intersect, enter, enter, enter. Oops, I don't have it on the right curve. Second, calc, intersect. want it on the black curve, enter, and then the red, pink curve, enter. And then I see that these two functions cross at y equals 122.87. That's what I want to know. That's my cost. What I want, that's what I inputted. This is what I want to know. It's 2,849.9 kilowatt hours. Okay. All right, let's take a look at the next section. So in this one, I'm calculating the wind chill, okay, at 30 degrees Fahrenheit. So in other words, I want to know, what does it feel like out there when I have a certain wind speed? So wind chill factors are used to measure the effect of the combination of temperature and wind speed. So we're going to keep our temperature constant at 30 degrees Fahrenheit, and we're going to change our wind speed. Okay, we want to know what that combination of temperature and wind speed on human comfort makes the temperature feel colder depending on the speed of the wind. So it does this by providing equivalent air temperatures with no wind blowing. One formula that gives the wind chill factor of 30 degrees and temperature and a wind with the velocity of v, so that's our variable, in miles per hour is this piecewise defined function. Okay, so what we want to know is we want to find the wind chill factor for a 30-degree temperature if the wind is blowing 40 miles an hour. Okay, so what does that feel like outside if the wind is blowing 40 miles an hour? Well, my subdomains here go from 0 to 4 miles an hour, then from 4 to 55.9 miles an hour, and then greater than 55.9 miles an hour. So because v is equal to 40 is in the interval, 4 is less than or equal to v is less than 55.9. The wind chill factor is going to be the second piece of the piecewise function. So we're going to enter 1.259 times 40 minus 18.611 times the square root of 40 plus 62.255. All right, so what does that look like? I'm going to enter it in one fell swoop. 1.259 times 40 minus 18.611 times the square root of 40 plus 62.255. Oops, I don't want to graph that. Okay, so this is equal to negative 5.091. Okay, so essentially it's approximately negative 5 degrees. It feels like it's negative 5 degrees. Okay. All right. Find the wind chill factor for the 30-degree temperature if the wind is 65. All right, so that's this piece. So because the wind chill factor, because the wind chill factor, I gotta plug in my V, or because the temperature V is 65 miles per hour, and that is greater than 55.9 miles per hour, then we can simply say that we're going to use this last piece, namely that the wind chill factor is negative 6.5. So it doesn't go beyond that. All right. So the last piece asks us to graph this function. So we're going to enter this into our calculator, which I have already done. All right. So your function should look like this on your calculator. Okay, and probably the trickiest piece is that middle domain restriction. Okay, so 4 is less than or equal to x is less than 55.9, enclose everything in another set of parentheses, and we're going to let our domain and range restriction be 0 to 70, that was given by the problem, and then negative 8 to 30 is going to be our y. All right, so let's take a look to see what this is going to look like. All right, so there's our piecewise defined function, okay, and it looks something like this. Okay, and then the domain and range in part C is right here. So the domain is 0 to 70 and the range is negative 8 to 30.